Okay, this is the homework explanation 9.5b. Let's get started. So number three, when we are looking at the tangent, we know that for the a value equals to 1, the a value is basically uh, talking about it's going to be steeper or flatter. It's not the amplitude like the cosine or sine, okay? So in this case, equals to 1, so it's neither, not flatter, not steeper, okay? B value equals to 1. So basically telling you that the period, usually by default, tangent has a period of pi. So you're going to use pi to divide it by b value. In this case, it's going to be pi. Unlike the cosine or sine, it's going to be 2 pi. Okay, tangent is just pi. Okay, so when you guys are graphing the tangent, so you got to know that the period is 1 pi, but half of it is going to be on the positive side, half of it is going to be on the negative side. So you gotta split it in half. Okay. Before we do the translation, we're gonna just grab the parent function. Okay. Now you're gonna determine what's gonna happen when we have a theta plus 3 pi over 2. So here tells you that it's gonna go left by 3 pi over 2. Okay. So the the positive pi over 2 is going to shift towards the left by pi over 2. That's going to be at negative pi. Okay, and this one, we use a different color. The negative pi over 2 shift towards the left by 3 pi over 2. It's going to be at negative 2 pi. Okay, right in the middle, it's going to be negative 3 pi over 2. Okay, so we know that the period is going to be in between negative 2 pi and negative pi. So you can just go ahead, grab the curve passing through negative 3 pi over 2, and this will be your answer for number 3. Sorry. Next one, number 7. So the a value equals to 1, so neither steeper nor flatter. Good. In this case, look at b equals to 1, which means that your period is going to be just pi. Okay, so we can just go ahead and just grab the parent function for cotangent. So cotangent is going to be slightly different in terms of the way the curve is going. So first of all, you need to know that for a period, it's going to be between 0 and pi. Okay, right in the middle, it's going to be pi over 2. So when you're graphing this, the parent function is going to look like this. It's like the opposite of tangent. Okay, now let's analyze the translation. So theta plus pi over 2 is going to go left by pi over 2. Okay, so which means that the pi is going to shift towards the left. Everything is going to shift towards the left. Okay, so your new period is going to be in between negative pi over 2 and pi over 2. It's going to be a new period. And then you have to look at the negative 1. You bring this to the back, it'll look a little bit more familiar, like the y-intercept. So minus 1 means that it's going to go down 1. Okay, so look at the midpoint where it's passing through, where the curve is passing through. Okay, now it's going to shift towards the left by pi over 2, but it's going to go down 1 by 1. So this is the point that we're passing through. Okay, so your curve is going to look like this. So that's for number 7. Okay, so homework explanation for 5.7. Let's get started. So this is for you, Dylan. Okay, so first of all, let's look at number 17 from the textbook. Complicated, right? So first thing you want to do is try to rewrite everything in terms of cosine or sine. So I'm going to write that as 1 over sine square x. And then cotangent, I want to write it as cosine square x over sine square x. Okay, using the identity sine negative x is basically negative sine x. Cotangent is cosine x over sine x. Okay, so now I got some work to do. I'm going to multiply everything and I'm going to subtract the numerator. Okay, so go ahead and do that. So 1 over sine x, 1 over sine square x, subtracting cosine square x over sine square x, so it's going to look like this on the top. 1 minus cosine square x over sine square x. Okay, this is the top. On the bottom, you know that negative sine x, you can cancel out with the sine x in the denominator, so it just becomes negative cosine x. Okay, now here's some little work we can do. Keep in mind, you know that cosine square x plus sine square x equals to 1. Okay, so which means that if you subtract cosine square x on both sides, it's going to equal to sine square x on the left side equals to 1 minus cosine square x on the right hand side. This is basically that, right? So I can also rewrite this as sine square x over sine square x, everything over negative cosine x. This is basically just 1, right? So this is 1 over negative cosine cosine x, which equals to negative secant x. Number 19. So number 19, we know that using the identities, one of the identities, you know that cosine pi over 2 minus theta, this is equal to sine theta. Okay, with that being said, so cosecant is basically 1 over sine theta. Okay, I'll just get started with some work. So you can write that as sine theta divided by 1 over sine theta plus cosine square theta. Okay, what I'm going to do right now is I'm going to change the division to multiplication. And what that does to the fraction is that this is going to be the reciprocal. So it's going to just become sine theta over 1, which is sine theta. Okay, so sine theta times sine theta, it's going to be sine square theta. You're going to add the cosine square theta, which equals to 1. Last one, number 29. So this one's going to be slightly complicated, so I'm going to work on the left side and see if I can get to the right side, okay? So first of all, I see that sine x and 1 plus cosine x, they do not have the same denominator. Okay, so what I'm going to do is I'm going to multiply 1 plus I'm going to get the common factor, right? So sorry, I'm going to make these two the common factor, so just multiply each other. So 1 plus cosine x over 1 plus cosine x. And for the other side, I'm going to multiply by sine x over sine x. Okay, so look at this. See what's going to happen is I'm going to have 1 plus cosine x times 1 plus cosine x. Okay, on the bottom is going to be 1 plus cosine x times, it's a bad way to write it, times sine x. Okay, plus 1 plus cosine x times sine x. On the top is going to be sine square x. Okay, you see that I got this uh, common denominator. So I'm not gonna waste more space. I'm gonna just erase some parts and just add the two fractions up. Okay, so here we go. Bridge them. Okay. All right, so I'm gonna do the FOIL. So 1 times 1, 1 times cosine x, cosine x plus, times 1, cosine x times cosine x. So what I'm gonna get is, I'm gonna get 1 plus 2 cosine x plus cosine square x plus sine square x, everything over 1 plus cosine x times sine x. See if this is equal to 2 cosecant x. Okay, so what's going to happen is that you know that cosine square x plus sine square x, this is going to equal to 1. Okay, and then you can combine the like terms. 1 plus 1 is equal to 2, right? So we got 2 plus 2 cosine x over 1 plus cosine x times sine x. See if this is equal to 2 cosecant x. Okay, I'm gonna factor out the 2. So on top, it's gonna become 2, 1 plus cosine x. Okay, now we can do some canceling right here. Cancel out. Okay, now what's going to happen is you see that whether is 2 over sine x equal to 2 cosecant x. Yes, it is, because 2 over sine x is basically saying 2 times 1 over sine x. And you do know that 1 over sine x is equal to cosecant x. Okay, that's it for the homework explanation. Good luck.